As more and more individuals get used to the central role that the technology plays in their day-to-day lives, the importance of technology in social relationships is growing. It is without a doubt that the case that the proliferation of COVID-19 and the new normal has made this statement even more accurate, and the dating behaviors of individuals are not an exception to this trend. Tinder, a mobile dating application, has seen an increase of more than 60% in the number of individuals using it since 2014. On average, nearly 1.6 billion swipes are performed every single day on the app. This increase has been helped along by the epidemic, and the parent company of Tinder, Match Group, has reported that memberships and downloads have increased in recent months in comparison to what they were before COVID-19 outbreak. There is no longer any stigma attached to utilizing online dating platforms, and as these networks continue to gain popularity among those who are already not in a relationship, it is fascinating to examine how they function. Tinder's algorithm. When discussing social networks in today's day and age, the term algorithm comes up rather often in a meaning that this is less formal. The phrase alludes to the efforts made by social media platforms to find out what it is that we are doing so that they might improve our happiness. In the field of machine learning, an algorithm functions very similarly to a computer programming in that it uses computational techniques to learn directly from data rather than relying on a model equation. Tinder's matching system has undergone significant development since the launch of the dating app, which is reasonable given the increasing number of users and the data they provide. It is very clear that its primary purpose is to match individuals with one another in accordance with how well they seem to be able to work together. Initially, users of Tinder were assigned to Elo score, which was a ranking system similar to the one used to rate chess player. A particularly intriguing aspect of the system is the manner in which Elo points were assigned. It's possible that you'll get the impression that some types of sophisticated artificial intelligence was utilized to evaluate the photographs and information that were posted by each user and determine the amount of attractiveness associated with each profile. It's not quite like that at all. Elo scores were simply assigned to profiles based on the number of right swipes that they received, with profiles that had higher Elo ratings being given more consideration. If profile A received a right swipe from a profile that had no Elo score of X, for instance, then that profile's Elo score would increase, but not as much as if it is received a right swipe from a profile that had an Elo score that was greater than X. The Elo rating system would put up a series of tiers by categorizing users according to how attractive their profile is. If the profile received a better Elo score, it would be placed in a higher tier as a result. Tinder would then display profiles with comparable scores to one another more frequently, based on the concept that individuals who have similar Elo ratings would be in the same tier of desirability and as a result be more compatible with one another. Tinder's matching algorithm has been updated to take into consideration a broader variety of criteria, including a user's location, age, and hobbies, with the goal of displaying more profiles that are likely to result in a successful connection. Its cutting-edge technology provides users with decent profiles based on an improved version of its previous algorithm, which was based on the user's physical attractiveness to other people. AI and ML contribution in Tinder. Tinder makes personalized recommendations via the use of an algorithm called VecTech. VecTech is powered by machine learning and artificial intelligence. Users of the dating app Tinder are referred to as swipes and swipers. According to Steve Leo, the chief scientist at Tinder, each swipe is mapped into an embedded vector that provides insight into the potential characteristics of the user. For example, extracurricular activities, education pursuit, interest, and employment. When the software detects that two built-in vectors are comparable to one another, which indicates that two individuals have comparable characteristics, it will make a recommendation that they get together. Because of this process, Tinder's algorithms are able to grow better and better at locating people who are both compatible and able to swipe right. Another machine learning based on approach that assists in effective matching is called word-to-vec. Imagine for a moment if this algorithm serves as Tinder's in-house linguist. In point of fact, TinVec looks at the characteristics of the users and learns from a large number of post-swipes, while word-to-vec is more concerned with words. In particular, it analyzes how individuals communicate verbally. Taking all of this information into consideration, swipes that are very similar to one another are grouped together into clusters, and users' preferences are represented by the embedded vectors that we discussed before. Users that have preferences that are similar to one another will be suggested to one another more often by the algorithm.